In this video, we're going to go through more examples of working with complex fractions. I wrote the steps in my previous video on how to approach these problems, but we're going to go ahead and just go through the same steps that we did in the last video, which I will make sure to link in the description box. Okay, so we're going to find the LCD for the smaller fractions. In this case, we have two smaller fractions, this one here and this one here, and they happen to both have the same common denominator. So that's the LCD. And I'm going to multiply everything by x plus 2. I am going to put it in parentheses though, because now I'm working with a binomial, which means multiplying is going to be a little bit different. Now, I'm going to cancel anything that can be reduced in the smaller fraction. So this first fraction here, the x plus 2 is actually going to cancel with this x plus 2. And this x plus 2 is going to cancel with this x plus 2, leaving me with minus 4 in the numerator and a minus 10 in the denominator. However, we have these first two terms that I'm not going to just ignore. So with this x plus 2 times the 2, I'm going to actually have to distribute the 2 in. So that's going to become 2x plus 4. And then distributing this 5 in, that's going to be 5x plus 10. Okay, so the 4's actually cancel, and I'm left with 2x over, okay, the 10's cancel also, over 5x. So the x's reduce. They can cancel as well. Cancel those out because it's a multiplication. And 2/5 is going to be my final answer. All right, let's try that again. All right, here we go. So this one, 4 fractions, and 2 of the denominators happen to be the same, the a minus 2, but the other 2 are different. So that means that the LCD is going to have to be made up of all 3 of the different denominators. The 2, I'm going to write that first, the a, and then the a minus 2. And I'm going to multiply every term by 2a, a minus 2. 2a, a minus 2. 2a, a minus 2, and 2a, a minus 2. And I'm going to cancel anything in the denominators that I see there. So in this very first fraction, the a's are going to cancel. And I'm left with, well, okay, so I could just multiply that out. That's going to be 2a minus 4 when I distribute the 2 in that's out here. Technically, there's a 1 here as well that would be multiplied in, okay? All right, second one, the a minus 2 actually cancels, and we're left with, all right, so 3 times that 2 is going to be 6, and it's a minus a. Second one, this, oh, that's interesting. I bet you that's a typo, the fact that it's 2 over 2. That's all right. We'll just deal with it. I just realized that. 2's are going to cancel, and that's going to leave me with, okay, so there's an a that's going to get distributed, but there's also a 2 here. See that 2? So I'm going to, rather than distribute it all in one step, oops, goodness me. Rather than distribute it all in one step, I'm going to go ahead and write 2a, a minus 2. All right, in this last fraction here, the a minus 2 cancels, and we're left with 5 times 2 is 10a, and it's plus. Okay, so let's distribute here. So let's see. The 2a minus 6a is negative 4a minus 4 over. Okay, so this one is going to distribute. That 2a is going to be 2a squared minus 4a plus 10a. Now that does simplify. So that's going to be negative 4a minus 4 over, okay, so 2a squared, and the negative 4a and the positive 10a will add up to be 6a. Okay, so we can factor this. We can factor out a negative 4, which would leave me with a plus 1, since that's the GCF. In the bottom, we have a GCF of 2a, and that would leave me with a plus 3. So I can simplify. The one thing I can simplify is the 2 and the 4. So 2 goes into this 4 2 times. So that would be my final answer. -2 times a plus 1. I'm not even going to distribute. I'll just leave that alone over a times a plus 3. Okay. Running out of space here. Oops. So that would be my final answer. But I think there was a typo on the original problem. That's okay. We'll just pretend it's fine. Okay, next one here. So for this one, we see two different denominators. So both of them are going to need to be included in the LCD. So the LCD on this one is y plus 2 and y minus 2. And I'm going to multiply everything by y plus 2, y minus 2. Now, I know a lot of people hate that I write this out 4 times in a row. I do it for a reason. First of all, it triggers your brain the memory of what we're doing right now. So I do it for memory's sake. Second, it helps you not miss steps. Often, people who try to skip doing this step and doing it in their head will forget to multiply everything, like they'll actually miss something. So it's to help me go a little slower so that I make sure I don't miss anything. Okay, so for the first fraction, the y plus 2 is going to cancel, and I'm left with, I'm just going to write it out, y times y minus 2. We're going to distribute. I'll just take an extra step and distribute in the next step. This one, the y minus 2 cancels, and I'm left with y times y plus 2 over y plus 2 cancels here in this third fraction, so I'm left with y times y minus 2. And here the y minus 2 cancels, and I'm left with y times y plus 2. Now, do not cancel. We got to distribute first, combine like terms, and then we'll see if we can simplify. Okay, so here we go. That's going to give me y squared minus 2y when I distribute. Here, I'm going to distribute this and this. I'm going to do 4 distributions. Okay, but they're going to look very similar. So this is going to be, but I'm distributing a negative y on this one. Notice that, right? See that? Negative. Okay, so that makes a difference. That's going to be negative y squared minus 2y difference. In the denominator, it's going to give me y squared minus 2y, but this one's a plus, so it's going to be plus y squared plus 2y. Okay, so in the numerator, the y squareds are going to cancel, and I'm left with negative 4y. Oops. In the denominator, the 2 y's are going to cancel, but the y squareds are going to add up to be 2y squared. Okay, so I can reduce the 4 and the 2. Oops. That's going to be, sorry, the computer's a little slower than me. When I tap the colors, it's just a little bit behind. There we go. Okay, sorry. So we're going to do the 2 into the 4 is going to go in 2 times. And then actually, there's a y in the numerator and there's 2 y's in the denominator. So here, I'm just going to cross off the exponent, leaving me with 1 y in the denominator. So here's what I got. Negative 2 in the numerator over y in the denominator. And there we go. That's how we kind of deal with these more complex versions. Same process, clearing the fractions, but we need to make sure to simplify before we start trying to do any sort of canceling. Okay, so we can't cancel when it's not, fully simplified, because then we'll try to factor when we do that. All right, let's do one more. This one, I'm actually going to have to factor that first fraction before I even get to do the LCD. So this first fraction, which is going to thankfully factor into the same denominators in the other two, and x minus 4, x plus 4. I said it backwards from how I wrote it. But there is our LCD. X plus 4, x minus 4. All right, here, I'll squeeze that up here. LCD is x plus 4, x minus 4, and I'm going to multiply everything by that. And yes, I am going to write it out. I don't want to miss anything. Okay, and I'm going to start canceling. So in the first fraction, everything cancels, the x plus 4 and the x minus 4. On the second fraction, the x plus 4 cancels. And on the third fraction, x minus 4 cancels. So here's what we're left with. In the first term, we're just left with 6. In the second term, we have a negative 5 and an x minus 4, which I'll just take an extra step and distribute, over a 1 times x plus 4, which is just x plus 4. Okay, so let me distribute that negative 5, which will be here. Let me give myself a little space. I'm going to come backwards a bit. So 6 minus 5x plus 20 over x plus 4. Okay, so the 6 and the 20. Oh, yeah, I did that right. 20 times 5. Okay, the 6 and the 20 are going to add up to be 26. And that doesn't factor. We can't pull out a GCF or anything, so that is the answer. So when we have to factor, we'll factor first and then go through the process of finding the LCD and canceling and then simplifying completely before we try to do any sort of simplification for the whole thing. And that is complex fractions.